Good morning, or afternoon, or evening, depending upon what time you are watching this video. This is a lesson on section 11.2, which is carrying out significance tests, what we've been talking about the last couple days. And I love the cafeteria fries, but lately I feel like I just haven't been getting enough fries. I feel like my cups of fries are a little short these days. So I'm going to actually conduct a significance test to test this theory that I feel like I'm getting shortchanged on the fries. So this you should copy down in your notes. The significance test, there are 4 steps to success. These are the 4 kind of key points of a significance test that you will need to get full credit. The first thing are the hypotheses. That's H sub 0 and H sub A, the null and alternate hypotheses, and of course to find the parameter. Step 2, you got to check the conditions. I apologize, it is the most annoying part of the problem. However, this simple random sample is probably one of the most important things. If our sample's biased, then no matter how good we are at calculations and using the calculator and whatnot, those numbers aren't going to be real accurate if it's a biased sample. Step 3, my favorite part, the calculations, the fun part. Sketch the graph, calculate the test statistic, and get the p-value, and then you use that p-value in step 4 to make a conclusion. You're either going to reject or fail to reject the null hypothesis. You're going to compare alpha to the p-value, and you're of course going to apply that to the context of the problem. Okay, so here we go with the fries. A small cup of french fries in the cafeteria is supposed to hold 55 fries when full. You believe that the cafeteria workers who fill the cups are shortchanging the students, perhaps eating a few behind your back. Being a super statistics student, you decide to conduct a hypothesis test. You take a sample of 30 cups and find the average number of fries is 53.5. Is there evidence at the 5% level that the cafeteria worker is averaging less than 55 fries per cup? Use a population standard deviation of 4 fries. Okay, so we're going to walk through the steps. Step 1, the hypotheses. All right. Now, off to the side, also part of the hypotheses, we're going to write what kind of test this is. This is a one-sample z-test. And it's a z-test because we know the population standard deviation, or sigma. Okay, so here are our hypotheses. The null hypothesis. Remember, null means no change. So if there's no change in the amount of fries in your cup, then the mean fries per cup will be 55. All right. The alternate hypothesis. We believe that we are being shortchanged. So, and often it says it in the problem. Sometimes you got to kind of figure it out. But it says here, is there evidence at the 5% level that the cafeteria worker is averaging less than 55 fries per cup? So less than 55. And we have to identify what mu is in this case. And mu is the number, or rather the average, or mean, number of fries in a small cup. Okay, so there's step 1. That's it. Not too bad. Okay, step 2. We check the conditions. All right. Now, we go back up to my sample. Okay, so the first condition is a simple random sample. And it doesn't say anything about the sample being random. So we can't say stated in the problem. So we're going to say assume or results may be biased. And that's kind of identifying that we don't know if it's a random sample, but we know that it's important, and we're still going to go through with the math, but the results may be biased. Okay, normal. All right, so in this case, we're looking for n greater than or equal to 30, and 30 is greater than or equal to 30. So the central limit theorem applies. So even though I don't know anything about the distribution of the population of all small cups of fries, I know that as long as I have a large sample size, 30 or more, that the distribution of the sampling distribution will be approximately normal. And the last one, independent. And that, of course, is our population greater than or equal to 10n. And, of course, this is 10 times 30, and that's 300. So I'm going to go ahead and say that there are more than 300 cups of fries in the population. So that one is met as well. All right, now we move on to some fun stuff. Calculations. Calculations. All right, now, first thing we're going to do is we're going to identify the formula that we're going to use in this problem. And we're going to use a z formula because it's a one sample z test. So z star equals x bar minus mu over sigma sub x bar. Okay, now we're going to draw our approximately normal graph. We label the mean 55. Okay, that's what the mean amount of fries, mu. Okay, in our sample, we got 53.5 fries. That's an x bar. We're going to end up finding that area there. We have to recalculate standard deviation of x bar using, of course, the formula sigma over the square root of n. So our standard deviation was 4 divided by the square root of 30. And again, these numbers I'm just writing here because I have them, oddly enough, memorized. But they're coming from up here. Supposed to hold 55 fries. We're testing to see if it's less than 55 fries. So that's a mu. That comes from the population. The average number of fries is 53.5. That's an x bar because that comes from my sample of 30 cups. Now this 5% is the main new thing that we'll deal with kind of towards the end in the conclusion. Okay. So when I take 4 divided by the square root of 30, I get 0.7303. So the next thing I'm going to do is plug into my z formula. I'm going to get my z score. Okay, z equals 53.5 minus 55 over 0.7303. So that's, again, my x bar right here minus the mu right here divided by this recalculated standard deviation. I get a z score of negative 2.05. And I'm going to use normal CDF. Negative 1 and a bunch of zeros, comma negative 2.05. And that's going to give me 0.020, 2. All right, and feel free to pause this and check in your calculator so that you make sure that you're understanding where these numbers are coming from. So that's 0.0202, and that we have a new term for is now called the p-value. Okay. So that's it for the calculations. Not too bad. A lot of that's a review. Now we step down to the conclusion. Okay, now, one thing that we're going to look at is our alpha value. Our alpha value is 0.05, and that's the 5% from the significance level up here at the top. Okay, so alpha equals 0.05. Now, if we look at the p-value of 0.02, we notice that 0.0202 is a very small number. It's only about 2%, and it's less than our alpha of 0.05. So we've got a cutoff here, which is alpha, and anything outside of that, we're going to reject the null hypothesis. We're going to say that that number is so small, that that probability is so unlikely, that we're willing to reject the null hypothesis, or the true, whatever we believe the mean is. So according to this decision, this is how our conclusion goes. we will reject the null hypothesis, mu equals 55, at alpha equals 0.05 significance level. Okay, comma. Why are we doing this? Because the p-value is less than alpha. So again, that's this 0.0202 is less than 0.05. So that makes it real concrete. It doesn't make it a guessing game anymore. If it's less than alpha, then you reject. Now, what does that mean in the context of the problem? We have evidence to believe the mean number of fries is less than 55. Okay? So, again, if I'm looking at this, I'm going back here and I'm reading this. Is there evidence at the 5% level that the cafeteria worker is averaging less than 55 fries? So I kind of recopied that. We have evidence to believe that the mean number of fries is less than 55. Okay, now I'm going to go off on a side note here, and let's say that, just for the sake of understanding it, let's say, to give you another example, that alpha was 0.01. So it needed to happen less than 1% of the time for me to reject the null hypothesis. So if we change alpha, that changes the outcome of our problem. So in this case, 0.0202 is greater than 0.01. So it's not small enough. It's not unlikely enough that I'm going to reject the null hypothesis. So how that would read is we will fail to reject the null hypothesis, mu equals 55, at alpha equals 0.01 significance level. Okay, and you'll have to excuse my writing. My smartboard's a little off. Comma, since the p-value is greater than alpha. And that, again, is the 0.0202, which is greater than 0.01. All right. We do not have evidence that the mean number of fries is less than 55. So again, we're failing to reject that null hypothesis. We don't have evidence to believe that the number of fries is less than 55. Okay, so you can see, and you're not going to do twice every single time. I just was doing that to show you what it would have looked like had we failed to reject the null hypothesis. Signing out.